chemistry teacher. Today in this session I want to discuss an acid basis, right? So in our surroundings so many substances are there. How to recognize in these substances as acids or bases? Okay, so in these acids or bases is in these substances very useful to our life. Okay, once check the what is the uses and how to recognize these acids and bases. Okay, right. So in acids, the first I want to discuss the definition of the acids and bases. Okay, protons donors are called acids, or electron pair acceptors are also called acids, and bases are proton acceptors. So electrons pair donors is also called acids and bases, right? Actually, in these, you can easy to identify them based on their formulas in acids and bases. Able to increasing H plus ions or concentration as an aqueous solution, that is called acids. Able to increase the OH minus ions. Okay, you have to observe here H plus ions, here OH minus ions in aqueous solution, right? Let's see. So what is the taste of the acids? Actually acids are so taste. Okay, and bases are bitter taste. Okay, for example, in natural acids and natural bases we can identify with the taste, and is available in the taste is a sour taste. Actually, in these basic substances are bitter taste. So right, in this when you identify these substances is sticky, and it is identify these substances easy, the soapy touch. When you touch these substances is soapy, smooth or soapy, right? Actually when you inhale these substances in our nose, it bonds to nose. Anyway, acid substance bonds nose, and it does not smell. Basic substances does not smell, right? In coming to that, the pH value of acids is less than 7. The value is the less than 7, that indicate that given the substance as acids. If the pH value is more than 7, that is the basic substances, right? Next, so these are the examples: HCl, H2SO4, HNO3, nitric acid, acetic acid. So these are the examples of acids. In common examples of bases: sodium hydroxide, potassium hydroxide, calcium hydroxide, and ammonium hydroxide. So how to identify these substances? How to identify these substances? Based on the indicators. We have to use some indicators to identify these substances. Okay, so indicators are mainly is classified into two types: the natural indicators and synthetic indicators. Okay, so natural indicators we have to identify the based on color and olfactor based on odor. So if you identify the substances to based on odor, like a smell, that substances, that nature is called olfactor indicators. That indicators are called olfactor indicators, right? Let's see. In these I easy to identify that indicate based on the indicators uh, by the color. For example, let's see, litmus paper. Litmus paper. So in this paper is available in laboratory. Is mainly two colors available in blue color litmus paper, blue, and the other one is a red litmus paper. If the blue litmus paper turn the color immediately in the substance, immediately change the color red color. Okay, for example, you have to take any substance in beaker or watch glass, and the substance is give immediately that color will be change the color the blue color. Actually the blue litmus paper changed to red color. That is indication of that the blue litmus paper, when you dip it in the solution, the blue litmus paper, actually this is a blue litmus paper thing, so it will immediately change the color red color. So that is indication that the given substance, to identify the substance, is acid. That is acid substance. For example, in this same another substance, so on that substance, when they dipped in the red litmus paper, if they change the color in red to blue, that indication the red color to blue color, that immediately they change the color blue color, indication the red litmus paper, actually red litmus paper change to blue color, the blue litmus paper change to red color, that indication that given the substance is acid. And if any litmus paper, the red litmus paper, the tone immediately that blue color, indication that is given the substance is basic substances. Okay, next some universal indicators are there, that is synthetic indicators. This is also called synthetic indicators. For example, that is a methyl orange, and another one is phenolphthalein. Methyl orange indicator, the dip in the solution is combined with acids. When this is combined with acid, the color methyl orange actually the colorless liquid. So when this is dipped in the solution of acid, it is immediately change the color red color. We can identify and simply remind this point is the methyl orange, MO. In this combined with acid, they immediately change that color red. You can easy to recognize this point, MOAR, methyl orange acid with red color. With the same condition is a methyl orange indicator with basics, right? The methyl orange is a orange color. The orange color in the when they combine with the acid, it immediately change the red color. The orange color of methyl orange is combined with the basic substance, immediately change that yellow color. If the color orange color the change to by yellow color, that is indication that given the substance is base. If the methyl orange color in when they combine with acid, they change the color the red color. So the given the substance is acids, right? Next, coming to the phenolphthalein. Phenolphthalein, this is also one of the indicator, and in this indicator is combined with acids, that is the change the color, it's a no change the color, is a colorless. So actually the phenolphthalein is a colorless liquid. So in this, when they dipped in the solution, in this add into the solution of the acids, it is no change the color, it remains same. In case that phenolphthalein indicator is combined with base substance, that immediately change the color pink color. So we have to identify these colors in table form. So this table is very important in 10th class level. So listen, here given the some substances like hydrochloric acid, sulfuric acid, nitric acid, acetic acid, sodium hydroxide, calcium hydroxide, magnesium hydroxide, and ammonium hydroxide. So in these some colors like litmus paper, these some indicators, the red litmus paper and blue litmus paper, and these are the indicators. These two are synthetic indicators. So methyl orange and phenolphthalein. When these substances, that are hydrochloric acid, So these are the acids, 1 to 4. These are the acids. When the dip in the litmus paper in the solution does not change the color, they remain same. But blue litmus paper immediately change the color red color. Okay, and in basic substance, red litmus paper change to blue color, and the blue litmus paper in that basic substance is no change. The color remains same. Okay, it's very important. And methyl orange, coming to the synthetic indicators like methyl orange and phenolphthalein, in the methyl orange with is combined with the acid, so immediately change that color red color. HCl, H2SO4 and HNO3 and CH3COH, acetic acid. So these are change the color red color. So when uh, basic substance like sodium hydroxide, calcium hydroxide, magnesium hydroxide and ammonium hydroxide, when this is dipped in the combined with methyl orange solution, immediately change the color yellow color. Okay, so in acids in with the phenolphthalein is a colorless. In acids in basic substance is a pink color. Okay, so that one important note point, the litmus paper in a neutral solution is a purple color. It is a purple color. Okay children, thank you, bye.